All right, so your lesson for P2, chapter prerequisite, section 2, which is a little bit of review on exponents. The first section here just has some properties. I'll kind of illustrate those properties as I work through other problems. But write them down if you need to, or just highlight them in your notes. Again, I'm not going to talk through them now, but just know that in these problems with exponents later on, that's what I keep coming back to again is these properties. I'm going to scroll down here to get to some of the problems themselves. So we're going to evaluate. Okay. So right here, if you had -5 squared, that's -5 times -5. Negative times a negative would be a positive, and it would come out to be positive 25. That's the significance of the parentheses, whereas right here, if the negative sign is just sitting out front with like the order of operations, you would square the 5 first. And then you just keep the negative sign out front. Okay, so those parentheses are significant if they're in there or not. Remember that 2 is to the first power. So we're multiplying two exponents with the same base. So we would add them up, right? 1 plus 4 would be 5, right? So this would be 2 to the 5th power. If you want to completely simplify that, 2 to the 5th is 32. And then here, this would be 4 to the 4 minus 6 power, or 4 to the -2nd. And keep going with these properties of exponents. That would be 1 over 4 squared, totally simplified to 1 over 16. 1 over 16. Okay. Here we throw in some variables. Okay, by the way, just to look ahead here, I'm going to cut that out. So I don't care if I use some of that space. We're not going to cover scientific notation in section 2. To simplify these, I'll start with the constants. Okay, so this would be equal to -12. And then both A's are to the first power. So I'd add those. 1 plus 1 is 2. And then B, again, I would add those because they're being multiplied. So B to the 4th, let's see, 4 plus -3, which would just be +1. And that would be it, -12A squared, B to the 1st. Okay? I guess the way to approach these is kind of constants, and then check for variables that have the same base. Now, something to always watch out for would be right here. I'm not doing anything with the 3A, but I do know that anything to the 0 power is 1. So even though that kind of looks like a mess inside of there, I'm not gonna do anything with that -4A squared, because that's 1. Anything to the 0 power is 1. All right, negative exponent, okay, which means I am free to take what's inside there which would be 10 over x, and that would be to the first power, which I can just drop and just say that that's 10 over x, okay? Okay, same thing here. I'm kind of taking this one at a time. The constants would be 3 over 15. All right, now I kind of work on the a's, right? And this would be split up as a to the -3rd over a to the 1st. Those exponents are going to have to be subtracted. And then I have b to the fourth over b to the negative first. All right, so I got 3 over 15. That's going to stay the same there. All right, so now I can go ahead and subtract my exponents. A, to get rid of that division, would just be to the negative fourth. And then b, 4 minus negative 1, would be 5. All right, so let's just continue. This one's also, that one's gone. Keep this down here. All right, so what I'm gonna do now is kind of get it back to a fraction. 3 on top, 15 on the bottom, okay? B to the fifth is kind of fully simplified, so right up here, I'll do b to the fifth. Down on the bottom, if I want to make that a positive exponent, that's where a to the fourth. So that'll flip and go down on the bottom. So that last one's got a little bit more to it. Definitely has a few more steps to kind of work through in terms of the simplifying, but there you have it. All right, so we didn't see any of these on the other slide, but how do we handle this case where if you have a fraction in the exponent, which in any algebra class, you can see this scenario come up in a lot of exponential expressions, okay? Now, just in terms of terminology, the number up top that you would call m, we'd call that the power. And the one on the bottom, here you see that called n. That's the index, okay? And here's where that gets really significant. Is if you were to switch this to a radical, and know that a radical is any expression that has a square root in it, the n is the root, and the m, or the power, will stay inside as the power, okay? So really that index is significant, that's whatever root you're taking. Like if that number is 2, then you'd be talking about a square root. All right, so here we have a radical, and we're going to switch it to exponential form. So with the radicals coming in, understand that we're probably going to be looking at final answers here that have some fractions in the exponents. Maybe not in all of them, but some of them. Okay? So in this expression here, we wouldn't write it this way, but the fact that it's a square root, there's a 2, and there's nothing written with the 3, so that would be to the first power. So the power is 1, the index is 2. You could say that that's 3 to the 1/2. Same thing here. There's nothing written there. You can assume that's a 2. (3xy) to the 5/2 power. (27) would be to the first power, so the index that you would pull in would be to the 1/3. Okay, now if you wanted to simplify that one more, you could. Cube root of 27 is 3. Right? It said to just switch it to exponential form, so you could certainly stop at 27 to the 1/3 power. All right, so that 4, funny, you can kind of read it a couple different ways. Is it x to the 4th or the 4th root? The way I'm going to do the problem is I'm going to say it's the 4th root, okay? So that x would be to the first power. So out here, I've got 2x. And this exponent here would become to the 3/4 power, okay? Now notice I've got two exponents that have the same base. This x is to the 1st power. So what I'm going to do here, I want to add those together, because if I'm going to be, in an exponential form and simplified, those two exponents that have the same base, they should be written as 1. So here's how I'm going to do that. 1 is the same thing as 4/4. So I'm more or less dealing with a common denominator with those exponents, and then I can just go ahead and add them together and say that that x is to the 7/4 power. Okay? Switched over to an exponent, there's no square root, and I fully simplified it too. All right, down here on these last three, and this will be it for the day. Okay? We're doing the exact opposite. We are sitting in exponential form, and we need to switch it to radical. Now, one of the first things I'm going to do here is say 1 over x minus 7 to the 1/2 power. Okay, so I flipped it and put it at the bottom of a fraction. I'm really almost there. You'll get to know this one pretty well. If you see the operation of the 1/2 power, that's the same thing as the square root, right? Because my base is x minus 7. That would be to the 1st power, right? Going back up to the equation up at the top, that's like m, right? It's 1. It's to the 1st power, and then the index is 2, so you end up taking the square root. All right, on this next one, we'd end up multiplying through those parentheses. So 2 times 2/5 would be 4/5, okay? No on this one. Sometimes you might think, hey, I'm supposed to add those. The case that we're looking at is different than this. Don't get those two confused. Okay, that's not the case we're talking about. The one I just drew in over there, you would add the exponents, but that's not the case we have here. Okay, it's a different property of exponents. And once we have it here, right, the root is going to be the 5th coming from that index, and then it's going to be, you're taking the 5th root of x to the 4th power. Now, what about a decimal, right? With all the, the little rule we have at the top for switching from an exponent to a radical, it doesn't work very well for decimals, and if that's what you're thinking, you'd be dead on the money. It doesn't. You'd want to switch to a fraction somehow, some way. Now, this one's not a terrible one, right? 3/4, but do keep in mind if you just, it's over 1, right? So if I moved the decimal place twice, I could add 2 zeros. So that might be like the first way that you get to, 0.75 is 75 over 100. Okay, that might be more useful if it's a really tricky fraction. 0.75, 3/4, that's not so bad to get that converted. Now our end goal here is to get into radical form. So I'm still here. 4th root of x to the 3rd. Okay, we'll call it quits there. Again, that is the end of the road here for our basic properties of exponents. That's all we have for the prerequisite chapter, Chapter P, Lesson 2.